I like to understand the world. I like to learn about new ideas. I like to think about problems, look at them in different ways, and finally get an answer to them.
Linus Pauling was convinced that understanding structure was the key to unlocking some of the mysteries of the universe.
To understand the human body, we must know its structure in terms of the cells that make it up. If we want to understand cells, we must know their structure in terms of molecules. If we want to understand molecules, we must know their structure in terms of atoms. And to understand atoms, we must know their structure in terms of electrons and nuclei. To understand nuclei, as the physicists are trying to do now, we must learn their structure in terms of protons and neutrons.
Linus Pauling wrote, "The study of the physical world, and I would say the biological world too, is a search for structure and not a search for substance." As a small boy, Pauling's interest in science was awakened as he played in the back of his father's drugstore in Condon, Oregon. His fascination with structure also began in his childhood when he collected and studied the structure of rocks and minerals. Pauling was introduced to chemistry by a boyhood friend.
One day when I was 13 years old, he said to me, "Would you like to see some chemical experiments?" And I said, "Yes, I would." We went into his house up to the second floor where he had his little bedroom, and he carried out about 3 experiments, which really astounded me. They pleased me immensely.
Pauling later said that he decided to be a chemist right then and there. He went to Oregon Agricultural College, now Oregon State University, where he excelled in every science and math class offered. He went on to study and then to join the faculty at the California Institute of Technology in Pasadena, California, where he was to remain for more than 40 years. After his 1925 graduation from Caltech, Pauling studied with European physicists who were developing the new theories of quantum mechanics. In 1931, he applied this training in physics to clarify the nature of the chemical bond. He recalled his discovery.
I was so excited and happy. I think I stayed up all night writing out, solving the equations, which were so simple that I could solve them in a few minutes. Solve one equation and get the answer, and solve another equation about the structure of octahedral complexes, such as the ferrocyanide ion in potassium ferrocyanide. And it didn't take me long to write a long paper about the nature of the chemical bond. And that was a great experience.
Pauling's work on the nature of the chemical bond transformed the way chemists work and think. In the spring of 1948, Pauling caught cold and had to stay in bed for a few days. Bored with detective and science fiction stories, he began to ponder the structure of proteins.
I took a sheet of paper and sketched the atoms with the bonds between them, and then folded the paper to bend one bond at the right angle, what I thought it should be relative to the other, and kept doing this, making a helix, until I could form hydrogen bonds between one turn of the helix and the next turn of the helix. And it only took a few hours of doing that to discover the alpha helix.
The alpha helix was a breakthrough discovery in understanding the structure of proteins. Pauling was a gifted teacher, able to simplify in ways that made his ideas accessible even to the general public.
Know a good bit about the structure of simple molecules. Now the time has come when we can learn something about the structure of complicated molecules too.
The human body contains many kinds of molecules, such as the water molecule, H2O, with only 3 atoms in it. Also, many very complicated molecules, among which are the proteins. Proteins are very important substances. I think that a human being may well have in his body as many as 100,000 different kinds of proteins.
Pauling's work with the large molecules of proteins and hemoglobin led to his idea that sickle cell anemia was a molecular disease. This concept opened the way for the whole field of molecular biology.
From what I know of the properties of these patients, I believe that this is a disease of the molecule, and that if we look at the blood of these patients, we shall find that the hemoglobin molecules are different from those of other people.
Pauling went on to prove that sickle cell anemia is indeed caused by an abnormality of hemoglobin molecules in red blood cells. In 1954, Pauling won the Nobel Prize for Chemistry. The prize was given for his work on the nature of the chemical bond. The first time the Nobel Committee had honored a scientist for the body of his work rather than for a specific discovery. Pauling's increasing interest in biochemistry led him to investigate mental disorders and the process of aging. He developed the concept of orthomolecular medicine and began a 20-year crusade on behalf of the molecular benefits of large quantities of vitamin C. In 1987, Pauling modestly summed up the secret of his astonishing career.
You aren't going to have good ideas unless you have lots of ideas and some sort of principle of selection.
A biographer wrote, Pauling's audacity was coupled with deep chemical intuition, and his overall ability to identify sound ideas and reject unsound ones was remarkable. Perhaps more than that of any other modern scientist, Pauling's work spanned all the levels of physical reality, from the submicroscopic world of elementary particles to the macroscopic world of living organisms. Pauling's genius was in his vast understanding of the nature of the universe, and in his inspired guesses about how the universe works.